So think about this for a second. What if an AI could understand our world, not just as a flat picture or some text on a screen, but in full three-dimensional space? Well, today we're diving into a pretty groundbreaking framework that's trying to do exactly that. It's called 3EDG, ground everything everywhere in 3D.
You know how AI can draw a perfect little box around a car in a photo? We've all seen that. That's 2D recognition, and honestly, we've gotten really good at it. But the real world, our world, isn't flat. And when you ask an AI to find the car parked behind the SUV, well, that's a whole different ballgame. That requires understanding space and depth and relationships. It is a way harder problem to solve. Okay, so let's really dig into this. This gap, between a simple, flat picture and the messy, complex 3D world we all live in, it's honestly one of the biggest challenges facing AI right now.
Take a look at this. On the left, that's what most AI is used to seeing. A flat picture. It can say, yep, that's a car. But on the right, that's the real deal. That's how a self-driving car has to see things, as a 3D point cloud. And in that world, it's not enough to just find a car. No way. The AI has to know its exact coordinates, its size, which way it's facing, all in real physical space.
And this is where we hit a major disconnect. A lot of the AI research you hear about, it happens in these neat, tidy, indoor labs. Like a robot arm learning to pick up a coffee mug. But for the really big stuff, like autonomous driving or advanced robots, the AI has to step outside. It has to deal with the absolute chaos of the real world. We're talking huge open spaces, viewpoints that are constantly changing, and just stuff everywhere.
And that brings us to the real heart of the problem. Reality is just messy. Let's talk about why it's so incredibly tough for an AI to get a handle on it. Okay, picture this. You've got a self-driving car, a drone flying overhead, and one of those robotic dogs walking down the sidewalk. They're all looking at the exact same street corner. The car? It's getting this super dense, detailed view from the ground. The drone is way up high, so its view is sparse, it's kind of patchy. And the robot dog? It's seeing things from like a person's height moving around. They're all looking at the same thing, but the data they're collecting is completely, wildly different.
So it all really boils down to three huge challenges. First, just the massive scale of the outdoors. Second, all those different viewpoints we just talked about. And third, the data itself is often sparse and just plain inconsistent, especially when things are far away. A truly smart AI has to be able to juggle all three of these things at once.
So the big question is, how on earth do you build one single AI that can make sense of all this messy, conflicting information? Well, that's exactly the puzzle that this new framework, 3ED, was built to solve.
The core idea here is really cool. It's called 3D grounding. And listen, this is way beyond just putting a box around an object. Grounding means you can give the AI a sentence in plain English, like, find the silver sedan, and it could pinpoint the exact cloud of 3D data points that represents that specific car in its understanding of the world. It's connecting language directly to 3D space.
From the outside, the whole process looks beautifully simple. Step 1, you give it a command, just like you're talking to a person. Step 2, the 3E engine does its magic, crunching both the words and the 3D data. And step 3, it spits out a perfect 3D bounding box. Think of it like an invisible cube that wraps around the exact object you asked for in the real world.
Now, you can't just whip something like this up overnight. Building the data set that powers 3ED was a huge project. What you're seeing here is the special tool they used where actual people had to go in and painstakingly match language descriptions to 3D objects. They had to be sure every description was perfect, because at the end of the day, quality data is everything.
All right, so how does this thing actually work? Let's pop the hood and look at a couple of the really clever ideas that make 3ED so good at what it does.
Okay, one of its biggest tricks up its sleeve is something called multi-scale sampling, or MSS for short. Here's the problem it's trying to solve. Imagine you're looking at a scene. If you zoom in really close on a small area, you see amazing detail on things right in front of you, but you're totally blind to what's in the distance, right? But if you zoom way out to see the whole picture, you lose all that fine detail up close. Everything gets kind of fuzzy. What MSS does is kind of brilliant. It does both at the same time. It samples the 3D world at a whole bunch of different scales, all at once.
So now you've got all this data from different zoom levels. That's where the second piece of the puzzle comes in, Scale-Aware Fusion, or SAF. You can think of SAF as the team manager.
It looks at all the different views from MSS and intelligently decides, okay, for this part of the scene, the close-up view is best. For that part over there, we need the wide shot. It then fuses all of that information into one single, solid understanding of the world.
Okay, that all sounds really smart on paper, but the big question is, does it actually work in the real world? Let's check out the results.
This chart right here tells a really interesting story. Look at the data from the vehicle view. It's getting a ton of information, like 462 data points for every object. And boom, the accuracy is over 80%. That's fantastic. But now look at the drone. Its data is super sparse, right? Only about 102 points per object. So as you expect, the accuracy drops to around 53%. This shows you just how much data quality matters, but it also shows that 3EED can still perform pretty darn well even when the data is thin.
Get this, they didn't just throw softballs at it, they didn't just say, find the car. They gave it these incredibly complex, descriptive sentences, like this one. I mean, this is a whole story. It's not just about spotting an object, it's about understanding a whole sequence of events and how things relate to each other in space.
And the result? It's pretty amazing, actually. Even with a query that complicated, 3EE'd nailed it, finding the right pedestrian with almost 79% accuracy. That's a level of understanding that just blows simple object detection out of the water.
Okay, but let's have a reality check here. No system is perfect, and the researchers are really open about this. The more cluttered a scene gets, the harder the task becomes. In a simple scene with just a few objects, the accuracy is great, over 71%. But when you start packing that scene with stuff, the accuracy drops to around 31%. And that really shows us where the next big challenge is for 3D AI, learning to handle the chaos of really crowded environments.
So what's the big picture here? What does all this mean for the future? Well, 3ED isn't just some cool research project. It's really a stepping stone to a whole new kind of AI.
I mean, think about the possibilities. We're talking about robots in a warehouse that can understand instructions like, go get the box behind the blue shelf. Self-driving cars that have a much deeper feel for the road and everything on it. Or augmented reality that doesn't just feel painted on top of the world, but truly part of it. This kind of spatial intelligence, understanding 3D space, is the missing ingredient.
So, if you take one thing away from all this, let it be this. 3DE'd is so much more than just a better way to spot objects. It's a fundamental step towards an AI that doesn't just look at our world, but actually perceives it, reasons about it, and one day will be able to act within it. What it does is bridge that massive gap between our words and the physical world in a really powerful way. And that leaves us with one last really big question to think about. As AI gets this good at seeing our world in 3D, what on earth is it going to understand next?